Hello everyone, this is Architalia. Welcome to my channel Darshonium. In today's video, we learn how to find out the group, period and the block of any element from its atomic number. So, it is very important that you should know how to find out the electronic configuration. So, if you don't know how to find out the electronic configurations of various elements from their atomic number, you can view the video that I have already made on how to find out the electronic configurations of various elements from their atomic number. The link of that video I will mention it in the description below. So go and watch that video first. Once you get how to find out the electronic configurations, then you can find out the block, the period and the group of various elements very easily. So let us learn how to find out the block of an element. In order to find out the block of an element, see where the last electron enters while writing the electronic configuration. So for example, let us take example of chlorine. The atomic number of chlorine is 17 and hence the electronic configuration is written as 1s2, 2s2, 2p6, 3s2 and 3p5. The last electron, the 17th electron has entered, as we can see, is in the p subshell and hence chlorine belongs to p block. Now let us take one more example. We'll take example of sodium. The atomic number of sodium is 11. So the electronic configuration is 1s2, 2s2, 2p6 and 3s1. The 11th electron of sodium has entered in the 3s orbit and hence the sodium belongs to the s block. Now let us move ahead. Now we learn how to find out the period of an element from its electronic configuration. So in order to find out the period, see the maximum number of subshells present while writing the electronic configuration. Now what does this mean? जो principal quantum number or the numbers which are present ahead of the subshell, we have to see in the electronic configuration which is the maximum number which is present. That number represents the period. To understand it easily, let us take an example. We'll take the example of potassium. The atomic number is 19 and the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Right? Now what we have to see, the maximum number of subshell. As we can see here, the subshells are 1s, 2s, 2p, 3s, 3p and the maximum one which is present is 4s. So here from this electronic configuration we can say that the potassium belongs to period number 4. Let us take one more example. We take example of iron. The electronic configuration of iron is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. As we can see, the last electron is entering in the d orbit, but we have to see the number of subshell. Here we can see the maximum number which is present, as we can see, is 4s which is there and hence iron belongs to period 4. And if we want to find out the block, iron belongs to the d block. As we can see, the last electron has entered in the 3d subshell. So now let us learn the last and final thing, which is how to find the group of an element from its atomic number. In order to find out the group, it is very important that we should know how to find out the block. Once we know how to find out the block of an element, it is very easy to find out the group. Suppose that my elements belong to the block S. So the number of electrons in the outermost orbit of the S block represents the group number. If it is S block, it can have only 1 or 2 electrons, right? So if there is 1 which is present, then it belongs to the group 1, and if 2 electrons are present in the S orbit, then it belongs to the group 2. So if it is 1, then group 1. If it is having S2, then it belongs to the group 2. Let us understand this within example. We will take the example of very simple element which is lithium. Atomic number is 3. So the configuration is 1s2 2s1. As we can see, the S block, it belongs to S block, right? And it has one electron, and hence we can see or we can conclude that lithium belongs to group 1. So in the similar way, we can take the example of magnesium. Magnesium, the atomic number is 12. The electronic configuration is 1s2 2s2 2p6 3s2, right? So we can see here the outermost electronic configuration is having S block and it is having 2 electrons, and hence we can see that the magnesium belongs to group 2. Now, let us take an example of element belonging to a p block. If the element belongs to the p block, then what we'll have to do is we'll have to add the number of valence electrons or the number of electrons which are present in the last p shell, plus we will have to add 12 to it. So the formula is adding 12 to the number of valence electrons which are present in the p subshell, right? So let us take one more example. We'll take the example of silicon. So the electronic configuration of silicon is 1s2 2s2 2p6 3s2 and 3p2. As we can see, this belongs to the p block, right? And it is having 2 electrons in the p shell. So what we have to do is we'll have to add 12 to it. So 12 plus 2 is 14, and hence we can conclude that silicon belongs to group 14. Isn't it very easy? And now let us take last and final thing, which is how to find out the group of the elements belonging to the D block. If my element belongs to the D block, then the rule is we'll have to add 2 plus the number of valence electrons in the 3D shell. Let us understand this with an example. We'll take the example of vanadium. The atomic number is 23. The electronic configuration is 1s2 2s2 2p6 3s2 3p6 4s2 and 3d3. As we can see, it belongs to the D block and it is having 3 electrons in the 3D subshell. So the rule says we'll have to add 2 plus valence electrons, which is 2 plus valence electrons are 3. So 2 plus 3 is 5, and hence we can say that vanadium belongs to group 5. Isn't it very easy? So this was today's video on how to find out the block, the period and the group of any element from their electronic configuration. Please make sure that you practice it again and again so that you get used to it, and it would become very easy for you to find out the block, the period and the group of any element. So I hope you liked this video. If you liked my video, please smash out the like button. If you have any suggestions or any queries, please comment right below. Please share this video with all your friends. Thank you for giving me all your time. I hope everyone enjoyed. सब लोग मजे करो. Thank you.